In this video, we want to write the equation for a tangent line to the curve f of x equals x cubed minus 3x at the point 1, negative 2. And we're asked specifically to find the slope of the tangent line using the limit definition. The limit as h approaches 0 of f of a plus h minus f of a divided by h. So we first want to begin by determining the value of a. And a is the x value of our point of tangency. So in this case, a is equal to 1. And then just as a reminder, the y value of this point, could also be written as f of 1. It's the value that we would get if we substituted 1 into our function. So a equals 1, and then f of 1 is equal to negative 2. So our slope of our tangent will be the limit as h approaches 0. And now that we know the value of a, I'm going to input it here. So this will be f of 1 plus h minus f of 1, all divided by h. At this point, it's really important to understand the algebra of what f of 1 plus h is asking of you. Remember, this means that 1 plus h becomes our input. So we are going to substitute 1 plus h into our function everywhere we see an x. So this part is essentially going to become 1 plus h, the quantity cubed, minus 3 times 1 plus h. Therefore, we have the limit as h approaches 0 of the quantity 1 plus h cubed minus 3 times the quantity 1 plus h. Next, we need to subtract, and we want to subtract f of 1, which we could find by substituting 1 into our function, or we could realize that that's actually already been done for us, and the y value of our point, which is negative 2, that is the value of the function at 1. So we could just subtract negative 2. And then this is all divided by h. So now it would probably be beneficial for you to pause the video, go to a piece of scratch paper, and multiply out 1 plus h cubed. 1 plus h times 1 plus h times 1 plus h. You're going to need to distribute and multiply. I'm not going to actually show that right now in the video. So pause and make sure you multiply this out and come back and make sure that your work matches mine. Now we have the limit as h approaches 0 of 1 plus 3h plus 3h squared plus h cubed. Then we distribute our negative 3, so that gives us negative 3 minus 3h, as well as distributing our negative, or rather thinking of this as not distributing but multiplying. Negative 1 times negative 2 is positive 2. So your algebra skills really become important in a problem like this. Combining like terms, we notice that 3h minus 3h is going to subtract out. 1 minus 3 is negative 2, which subtracts out with the positive 2. So we are left in the numerator with just the 3h squared plus h cubed. And those terms share a common factor. So we can factor out a 3h squared. We'll be left with 3h squared times the quantity 1 plus h, all divided by h. And this allows us to divide out an h from the denominator and an h from the numerator. Notice in my notation here, I've continued to write the limit as h approaches 0 because I haven't actually evaluated this limit yet. But we're close. Now we have the limit as h approaches 0 of 3h times the quantity 1 plus h, which allows us now to do direct substitution and substitute 0 in place of h, which will leave us with a final answer of 0. So this tells us that the slope of our tangent line at the point 1, negative 2 is 0. Now let's think about what this actually means, and you could use your graphing calculator to graph the function, or if you just realize that it's a cubic, so it has an S shape. If a line has a slope of 0, then that means that the line must be horizontal. So that means that we have either found the horizontal line, tangent line, touching the curve here at that maximum point, or perhaps we found the tangent line, which is horizontal, here at the minimum. And if we dug in a little deeper to graph the function, either by hand or on our calculator, we would see that we have found one of these two tangent lines. And our final answer, which is the equation for the tangent line, since it's a horizontal line that must pass through this point, 1, negative 2, then the actual equation for our tangent line will just be the horizontal line, y equals negative 2. Let me demonstrate that quickly. Over here, just think about if it passes through the point 1, negative 2, and it's a horizontal line, slope of 0, then that has to be the line y equals negative 2. So this is the final answer for the equation for your tangent line. Now, for part B, we want to complete this exact same problem again, but we want to see how it will differ if we use this second limit definition for finding the slope of the tangent line. So, beginning the same way, we first identify our a value. So a is still equal to 1, and the output here would be the value f of 1. So f of 1 is equal to negative 2. And we'll begin by just substituting in our a value. So the limit as x approaches a will give us the limit as x approaches 1 of f of x minus f of 1, all divided by x minus 1. Now we know the actual function f of x, that was given. So the limit as x approaches 1, the function was x cubed minus 3x, minus, we also know the value of f of 1, that was the y value of our coordinate, so we'll subtract a negative 2, all divided by x minus that a value again, which was 1. So this limit will be the limit as x approaches 1 of x cubed minus 3x plus 2, all divided by x minus 1. Now we would try direct substitution, but we notice we cannot do direct substitution because that would give us division by 0. So we need to rely on some algebra. And our hope is that this numerator will factor. However, it's an x cubed, it's a cubic, so it doesn't factor by a traditional method. For example, like guess and check, trying to find two binomials. That method of factoring isn't going to work. So on this one, you have to use a more advanced method of factoring, which is really division. If you think of this entire problem here as a division problem, as if we're dividing x minus 1 into x cubed minus 3x plus 2, then we could use synthetic division to do this division, which essentially factors the numerator. So if we're dividing by the denominator, which is x minus 1, then this is going to be my side work over here off to the side. We're dividing by x minus 1, so that would put 1 in the box for our synthetic division. And then our coefficients, remember, we're using the coefficients of the numerator. This is a 1x cubed, a negative 3 for the coefficient of x, and then the constant is positive 2. So my coefficients are going to be 1. I am putting a 0 here because I'm missing an x squared term, and then I have negative 3 and positive 2. And I'm going to do my synthetic division. I drop down the 1. I multiply by what's in the box. 1 times 1 is 1. Then I add straight down. 0 plus 1 is 1. Multiply by what's in the box. Add straight down. Multiply by what's in the box. Add straight down. And my result here, this 1, 1, negative 2, these are the coefficients of my quotient, essentially, which would be x squared plus x minus 2. And the 0 at the end, remember, that is your remainder. That tells us that x minus 1 divides in evenly. So I'm going to rewrite this. I'm essentially going to use my synthetic division to show how we have factored the numerator. So the x cubed minus 3x plus 2 factors into x minus 1 times x squared plus x minus 2. Kind of a non-traditional factoring approach, which allows us to divide out the x minus 1s. And now we're to the point where we can do direct substitution. So using direct substitution, substituting in a 1, we have 1 squared plus 1 minus 2, which indeed gives us a slope of 0, just as we got earlier when we used the other limit definition. So we still have a slope of 0. Therefore, the equation for our tangent line is the horizontal line y equals negative 2. So some students may prefer using this limit definition here for finding the slope of the tangent line, as opposed to the previous one where we were using the limit as h approaches 0. They get you the same answer, however the algebra is a bit different. In general, if you choose to use the second one, the limit as x approaches a, you'll notice you'll get to a point where you may need to do some advanced factoring or division. So understanding synthetic division is often quite helpful if you're going to use this limit definition.